Welcome to the office. We want to take a short look at rewriting the multiplication table for D4, where we are going to kind of gather together our cosets from our previous examples here. So let's take a look at that. Again, here's a blank multiplication table for us, allowing us to express the order of the elements as those of the cosets. So I want rho naught and mu2, rho naught and mu2, based on our original subgroup. Now, for the cosets, we had a coset of rho 1 and delta 2. And you know what? Rho 1, delta 2. I want rho 1, delta 2. Excellent. Just double checking to make sure I grabbed onto the left cosets here. So left cosets, rho 1, delta 2, rho 2, mu 1, rho 2, mu 1. Let's see here, rho 1, delta 2, rho 1, delta 2, rho 2, mu 1. Rho 2, mu 1. And then, of course, the only thing that I have left at this point is rho 3. And I have mu, delta, so I have that other delta 1. Excellent. So I have rho 3 and delta 1. And if you were unsure, we can go ahead and double check that with our last coset, rho 3, delta 1. That looks good. Excellent. Now we go through the work of filling in this table. Again, we'll fill in part of it, and on the next page I have it completed. So we won't go through the whole thing. Rho naught times rho naught, of course, gives us rho naught. Rho naught is the identity element. So that won't change any of this. Mu2, rho 1, delta 2, rho 2, mu 1, rho 3, delta 1. And of course, this column will remain the same as well, with identity element rho naught. Mu2, rho 1, delta 2, rho 2, mu 1, rho 3, delta 1. Now, delta 2 times delta 2 gives us rho naught. Mu2 times rho 1, mu2 times rho 1. If we want to refer back to the previous page, mu2 times rho 1, mu2 times rho 1 gives us delta 1. Mu2 times delta 2, mu2 times delta 2. Yep, mu2 times delta 2 gives us rho 3. Mu2 times rho 2. Mu2 times rho 2 gives us mu 1. Mu2 times mu 1. Mu2 times mu 1 gives us rho 2. Mu2 times rho 3. Mu2 times rho 3 gives us delta 2. And mu2 times delta 1. Mu2 times delta 1 gives us rho 1. Now, if you have the table in front of you and you're able to just follow it along, it's actually pretty quick to fill in this entire table. I've demonstrated the initial row. I think that's probably enough for now. We can move on to the completed table. Now, what I'd like to do is I'd like to decide if our cosets define for us a coset group, which is not immediately obvious just by looking at it as it sits. In order for us to observe that, what I want to do is I want to highlight the various cosets. So I'm going to start with yellow for our initial coset, that of the original subgroup. So I just want to look for rho naught mu2 within our table. Rho naught mu2. And let's see here, rho naught mu2, but it doesn't appear as a square this time. Rho naught and mu2 are right here. Rho naught mu2 as a square. Let's see here, rho naught and mu2 does not appear as a square. Rho naught and mu2. So we're already seeing that they don't appear as squares. So I wouldn't really expect a color and a color to give me one color, right? So it's not going to be a group. So if you wanted to say, hey, I know it's not a group, we can move on, that's fine. What I'd like to do though is I'd like to complete our example by considering all of the cosets. So rho 1 delta 2, rho 1 delta 2. We can observe it as a square here, rho 1 delta 2, and as a square here, rho 1 delta 2. However, rho 1 delta 2 does not appear as a square here, and rho 1 delta 2, oh, that's not what I wanted. Rho 1 delta 2, oh, it does appear as a square there. Rho 1 delta 2. Cool. So we get 1, 2, 3 squares. Did I copy one of these wrong? I did. That one is not a square. Rho 1 delta 2. Copy carefully. Rho 1 delta 2, rho 1. There we go. Okay, that looks better. Let's move on to blue. So rho 2 mu 1, rho 2 mu 1, rho 2 mu 1, rho 2 mu 1. Very carefully here. Rho 2 mu 1, rho 2 mu 1. That looks good as well. And now here we have rho 2 mu 1, rho 2 mu 1, rho 2 mu 1, rho 2 mu 1. And finally, rho 3 delta 1. Oh, same mistake as last time here. Here we are. Rho 3 delta 1, 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 and rho 3 delta 1. So the point is, in this example, that when I take, oh, let's see here, I missed this guy. There we are. When I take the product of, oh, let's see here, red and red, for example, I don't get one singular color, I get two. And that's a problem, right? That's just simply not well defined. When I take the product of two things, I can end up with two different things. Okay. So this does not, it should be pretty clear, this does not appear to be a coset group. Again, if we compare that to what we found in our previous example where we colored the graph, or sorry, not the graph, but colored the multiplication table, here we had everything appeared as squares. So when I took the product of two colors, I got one other color. In the current example, when I take the product of two colors, I could end up with one color, or I could end up with two different colors. And that, of course, would be a problem. So this does not define for us a group. If you wanted to take it in its most basic case, there's no identity element. All right. That's all that I wanted to share for that collection of examples now. And we want to move on to Lagrange's theorem, right? So nice conversation about cosets there. Now we want to take a look at Lagrange's theorem. So join me back here in the office for more conversation in just a moment.